you know, approach it similar to how some countries do like their law system. You know, like if, you know, where is it, Saudi Arabia, if you shoplift or something, they cut your hand off. Yeah, just have like a no tolerant. You cheat, you get decapitated. Always going to happen once. But you can't threaten something you're not willing to follow through with, because I think people don't believe it. Well, some countries you don't need to follow that kind of stuff. You should have broke the law. There's consequences to actions. Or I guess we can incorporate a Christian worldview into it, where you just, you know, drop them in the middle of the Arctic Ocean and just let God decide. This dude get a second chance or not? Well, I didn't suggest you chum the water first. I mean, we're giving them a chance. We'll even give them some of those flippers. I always thought that'd be a great thing for like the show Survivor, because it's been on for so long. And early, when it was the season one, you know, all these people like in tuxedos and stuff like that. And so, because they were at some party, then they, you know, must have grabbed him and dropped him off in some island somewhere. Well, now they're all wearing swimsuits and stuff. So you got to throw them a curveball, you know, dump them in the Antarctica, survive quick. Yeah, that could just be one of those 2-hour specials. Pay-per-view. This is all recorded too. It's great. Hey, look, you can't make any assumptions. I'm sure they made them sign waivers and stuff. Or put them out on one of those, the floating glaciers that like broken off, where you just have like one lone polar bear on that thing, and this group of people. Huh? I don't know. You want to get that close to a hungry polar bear?
Well, if you have like 6 to 10 people on the island, assuming they're somewhat strong, they could probably push the polar. The polar bear could easily.
Yeah, I'm not going to be the first one going up to push this polar bear. All right, let's talk about Towers of Hanoi now that we've talked about polar bears eating people. I just want to make sure we cover our bases. All right. So Towers of Hanoi. I think I looked at this right at the end of class last time, right? All right, and then you've done something crazy where you're trying to.
I haven't done number 8 yet because I accidentally refreshed the page. No, it removed the 500 moves that I had done.
I tried 8.
Yeah.
I almost got it.
Well, I mean, you know, it follows a specific algorithm.
Yeah.
So, I mean, once you like, if you write down the algorithm and just follow it, you should be able to do any number of them. Yeah, I don't know. But in any case, we're going to implement a simple 3-tower version. Each of these towers represents a stack. That's how we're going to implement this guy. Now, this stack has rules associated with it. You know, we talked about push and pop, and also peak for our stacks. And when we push something onto a stack, we're dropping it onto the top of the stack. But in Towers of Hanoi, the rule says that you can't put a smaller disk on top. Well, you can't put a larger disk on top of a smaller disk. All right, so, you know, I'm going to push it onto this stack. There currently is no disks on this stack, so that's allowed. If I tried to put this one on here, it would not be allowed. And the ultimate goal is to get everything to that far right tower. I'm pretty sure I did it. Yeah, minimum number of moves. That's the algorithm. All right. So we want to start designing this this guy. So we're going to need multiple objects. We're going to need a disk object. Let's get my Keynote open here. Towers of Hanoi. We're going to have a disk. We're going to have a, well, let's just list our things. We're going to have a tower. All right, so we're probably going to have a game object. So let's call this Towers of Hanoi objects. So disk, tower, game. Let's kind of start off with that. Now let's go and design the disk itself. So a disk is probably going to have like an int size associated with it. All right, when we think about our disks here, I can just restart. As I'm moving a disk from tower to tower, what I care about is what is the size of that disk? Because if I try to put a disk of a larger size on top of a disk that's smaller, it's not going to allow that. Okay, so the size of that disk is what's actually important. Do I need to keep track of anything else related to disks that seem to be obvious right now? Not that we won't evolve it or do something, but that seems to be all we need to keep track of. Okay, so now go ahead.
Would they know their, like, what, in the game, do they know, like, what?
Possibly, we might possibly need that, but let's kind of stumble upon, he's indicating that, does this disk here need to know that he's on this tower? Or does the tower know about the disk? Or maybe both? Something like that, yeah.
They're gonna need to know what's below them.
Do they? Does this disk care that there's a larger disk below him?
I mean, sorry, you might want to care more about this one above it. You can't just like move it without performing on top.
Don't you always pop from this tower? I can't choose to move this bottom thing. So whenever I'm interacting with a tower, I'm always popping from the top of the stack. So you don't need to know what's above you, because basically when you choose to move, you're saying pop from this stack, push to this stack. Pop, push. Well, that's what a stack is. Stack keeps track of the top. All right. So we're going to implement our towers as stacks. So generally when you're designing something, don't try to overthink it. Start with your baseline. And then if you stumble upon something that needs to be added, go ahead and put those things on top. All right. So we're going to have our tower. So our tower is going to be a stack of disks. And there's going to be some rules associated with our towers. We always pop from the top and push onto the top, i.e., this is a stack. A larger disk is not allowed to be pushed onto a smaller disk. All right. So let's say that's our tower. What's our game? If I go back here, I'm looking at this guy here. This is a game, correct? Or you can think of it as game board, whatever you want to think of. This is our game. So a game is a collection of 3 towers. Tower 0, Tower 1, Tower 2, something like that. All right. With a goal of getting everything into this last tower. All right. And we know we're good once we have, and we're going to start off by just having an array of 3 towers. So we'll have hard coded at 3 towers. We certainly could have a linked list of towers, right? Or we can have a infinite number of towers. And then you can even write the algorithm itself for it to self-solve and count the number of moves for the solution. You can do that, and it'd be a lot faster than spending your time playing Towers of Hanoi. It's like, I would imagine it's fun to a point, but at some point it's loses its shine a little bit.
At
8 discs. Once I rounded hour 17, I mean, it was still kind of fun, but not as fun. All right, so a game is going to be a collection of, for us, 3 towers with 3 discs starting on the far left tower, and a goal of getting those 3 discs on the far right tower. All right, that makes sense. So a game is going to have to provide a mechanism for making moves. What's a move? Which tower is the source? Which tower is the destination? Try to make that move. If it is legal, make the move. If it is not legal, reset to the previous state of the towers. Make sense? So that's what we're going to be trying to accomplish. All right, so our starting point here is to build these initial objects. So we're effectively custom making some Legos. We're gonna make a disc Lego, we're gonna make a tower Lego, we're gonna make a game Lego, and then we make those guys play together in a way that becomes somewhat interesting. All right, so let's go ahead and start off with our simple case. So let me close. All right, I'm going to go ahead and start a new folder for this guy. Towers of Hanoi. And we'll probably, as long as we don't run out of time. But yeah, ultimately we have a goal of doing that. We're going to need a stack to process our JSON.
Is that for like a deck of cards?
Well, you'll need a stack for a deck of cards as well, but you'll also, we need to parse that JSON. We're currently reading in a big string that's in JSON format. We need to write, we're going to write our parser. So to make sure we get the other abstract data types in. All right, so we're going to have a card.hpp. All right, and just as a reminder here, this guy, we have our class of something, we have our public, private, protected stuff, ends with a semicolon. So we're going to have, is it public or just class? It's class. So we're going to have class. It's not called card. Why did they call it card? Oh, because you were asking Towers of Hanoi. So we're going to rename this. It's called a disk. This will be our class disk. And then inside here, we're going to have a private section, and we'll have an int size. And then we're going to have a public section, and we'll probably have a getter for the size, as well as a constructor. So we'll have a disk, it's our constructor, and then we'll also have an int get size. So we need to implement those two functions. All right, so I'll steal those two things here. So now we're going to go ahead and create our disk CPP. So new file, disks.cpp, include disk HPP. All right, so we have those two things. What we're going to do for our constructor is we'll set this size equal to size. And then for get size, we'll return this size. All right, so fairly simple object, right? All right. Now, let's create our next object. We have our tower. Tower HPP. Now we decided that well, let's just start this class tower. We decided that a tower is going to have a collection of disks. Okay, so we're going to have a stack of disks. So I'll start off with a generic. It's going to be a collection of disks where a tower needs to remember what's the top of it, because this guy's going to operate as a stack. We certainly could implement this using an array and then kind of keep track of stuff, but that wouldn't be what the cool kids do, right? Cool kids know about pointers, and pointers point to things like, so maybe we have a disk that points to the next disk, for example. So a disk could kind of serve the purpose of a node. Similarly, we could create a node that holds a disk whose payload is a disk and move those things around. I'm not sure it necessarily matters, but I think we'll probably keep it at the disk level. So since a disk is we're going to say this guy lives on a stack, we also need to know about the next disk for our disk objects. Okay? Because ultimately, if we go and look at our picture back here, if this is a stack of disks, we're going to have a pointer called top that's going to point to the current top of that stack. This disk's next disk is this guy. This disk's next disk is this guy. All right, these guys live on a linear linked data structure, and that just happens to get used as a last in, first out queue. Last in, first out stack. All right, so we'll go and add to our disk type that we're also going to keep track of a disk pointer next disk. So then as part of the constructor, we'll initially say this next disk is equal to null. Oh, is it NULL? Standard lib. Yeah, but I think it's in standard lib.
Yeah.
All right, so there's our null value. We could have also set it equal to 0. That would have worked too if we didn't want to use standard lib. All right, so a disk is also going to now have a get next disk, which will return a node pointer. And it'll have a void set next disk, which will take a node pointer.
It should be disk pointer, right?
Yes, disk pointer. So then we'll implement those two guys. So this guy will return the next disk. This guy will set the next disk. All right, so there's our enhanced disk object. So now we're back to our tower. So our tower is going to operate as a stack. So back over here, this guy is a stack of disks. Since it's a stack of disks, we're going to have to keep track of a disk pointer called top. We might also want to keep track of the count, the number of things that are currently inside of that stack of disks. All right, so we'll have a private section here. And this guy will have a disk pointer called top. Now, right now, it doesn't know about disk pointer. So we need to include disk HPP. Now he knows about it. We're also going to keep track of a int count, the number of elements currently on this tower. Then we'll have our public section, and we're going to have our constructor for this guy. And when a tower is first constructed, it'll be empty, and then we will push things onto it, right? We're going to have the ability to get top, and this guy will return a disk pointer. Actually, we're not going to have an ability to do get top, because get top is actually a, depends. If we want to remove it, it's a pop. If we want to just view it, it's a peek, right? So we'll have a disk pointer pop, and we'll have a disk pointer peek. And then we'll have a void push that will take a disk pointer as a parameter. So those are the functions we need to implement inside of Tower CPP. So new file, tower.cpp, include Tower HPP. We'll go and implement these dudes. All right, so for our constructor, we're going to set initially a tower is empty, right? And what does it mean for a tower to be empty? It means that its top is null, and it means that its count is 0. Okay? So this top gets the value null. So we need to include standard lib. So we have access to that null value. Then this count is equal to 0. When a tower first is created, it has nothing on it. So its count is 0 and top points to nothing. If we pop from a tower, are there any rules associating with are there any rules associated with popping from a tower? Or we might not get anything off the tower if it is empty, right? So if I try to pop from this tower right here, I'm allowed to try to pop from that tower, just nothing's going to come off there. But there are no special rules associated with popping from a tower. Whatever's at the top, I'm going to remove that and I'm going to give it to you, right? So for pop, actually, let's take 2 minutes or so and try to write pop on your own. And then we'll write it. I'm not having you turn anything in, just let's have this be a little interactive rather than just watching me write code. This guy should remove the top element and return it. Or just return null if there is no top. All right, so let's take a look at this. We can go ahead and ask if it's empty. We don't want to do anything special, right? So how can we ask if the stack is empty? If top is null, it's empty, or what's no count 0. So if this count is equal to 0. That's one way we could have asked it. We could have also asked if this top is equal to null. That asks if it's empty. Or we could have also said if this top, this guy says, if the top is something, do something. Alternatively, could have said if not this top. So these three things all effectively say the same thing. I don't care which you use. Let's go with a count as 0. So if there's nothing in this function, or if there's nothing in this tower, we'll go ahead and return a null value. Else, I have to disconnect the current top and then return that disk, right? All right, so how do I disconnect the current top? Well, I'm going to need a pointer to point to the guy I'm going to return. So I'm going to need a disk pointer. We'll call this disk to return is equal to whatever the current top is. Then I can update top to point to disk to return get next disk. So whatever disk to return points to, I want top to now point there.
Could you also just say since this to return is equal to top, could you just say this top equals this top? Get next to it?
Oh, you mean this guy right here? Yeah. He's saying, could I've also said this? Yeah, those are synonyms. So pick your poison. I guess I probably would have said disk to return. One less arrow to write, I guess. But I don't, it doesn't matter. They ultimately are the same memory address. All right, so disk to return is we're gonna preserve the current top. Then we'll update top to be the next guy. Then we want to fully disconnect the disk to return. Because at this point, we have not changed what disk to return's next disk is. Presumably, we are going to be setting this guy's next disk to something new later on. But I like to follow a strategy of saying, if I'm taking something off a stack, he loses all connectivity to that stack. So I'm going to say disk to return, set next disk to null. This is the guy we're going to return, the current top. Update top to be the next guy, even if it's nothingness. Update the disk we're going to return so that he no longer points to any place. Decrement count. And ultimately return disk to return. All right, so that's pop. Go ahead. Yeah, it would delete it completely, but is that what we want? If we're popping this guy off the disk, we want him to still be a thing, right? But yeah, I mean, that's true. If we were popping this guy off the disk and then he just poof, then we could delete it. We weren't going to return it. Yeah, absolutely. In fact, you'd want to. You know, hey, I'm removing this from the top of the thing. I would say that for abstract data types, pop should always return a value. It's because it returns and removes, or removes and returns the value from the top of the stack. But if in your particular implementation that never actually makes sense, and you were effectively obliterating whatever's at the top of the stack just because, sure, don't return it, delete it. So that's our pop. Now, peak this guy here should be pretty similar. So this returns without removing the top element. Well, I kind of have some redundancy there. Returns without removing the top element, or just returns null if there is no top. All right, so go ahead and we'll do 2 minutes again to write that. See if you can see the difference between pop and peak. This one should be easier, but again, just to get some interactivity. Yeah.
So if this top equals null and you just return this top, that would be null.
Correct.
Right?
But along the lines of where you're going with that, that's adequate for this, but depending on what you're implementing it might be handy to have some sort of error message or something like that if you try to pop from a nothingness or something, depending on how you're using it. But I think in this case, what you're saying is accurate.
Also, I know that a stack doesn't normally have a function like feed the entire stack, but would that be helpful for
Probably displaying the contents of the stack. Yeah, that would probably be helpful. Yep. Yeah, so what he's suggesting here is maybe we should have a
I think the game would be a lot better if you only see the top of the stack.
maybe a display function that shows the current state of a stack.
I guess that might be in the game file instead of file.
Well, isn't it kind of in both? I mean, and then similarly, doesn't a disk need to be able to display itself?
So like the game called display called power display.
Which then calls each of its disks.
Okay.
Yep. So whatever we decide a disk should look like. Well, we could do like so we're not doing a GUI yet, or we won't do it in here, but we could use, I suppose, ANSI symbols for colors, but we're not, but we could. So if you wanted to challenge yourself, there's something called ANSI, ANSI, where you can, it's a special symbol thing. It's like a numeric thing beforehand, and that puts the terminal into like a mode for a certain color or something. Then anything you type after that will be in that color. Then you could turn it back off, put it back to the other color. So you could get some, obviously, I mean, just do ANSI graphics or ANSI art. So nothing says you couldn't have output that looks kind of like, color stuff like that. So have at it. Probably a better use of time than 8 stack towers of Hanoi. If
I might get it someday.
I wonder if there's a world record out there for most solved. Those classes used to exist. All right.
The fastest time to solve a 6-level tower Pinot is 31.92 seconds.
For 6.
Six stacks under the-
Is that randomized or do you start with the same person start with the same?
You always start with the far left, full stack. You just got to get everything.
Rubik's Cube, if you do it enough times, you do it.
Got more.
You get really, really fast. It will be your-
Have you seen those people like juggle Rubik's cubes and they are solving them while they're juggling them? Isn't that ridiculous?
They just grab that Rubik's Cube, you're randomizing it. It's that down, things like randomized.
Well, no, I mean, there people actually juggle it. There's competitions for. There's actually a Netflix documentary on like some guy who's like super fast with the Rubik's cube or something.
The video with like kids who put like stack up and wow.
You could stack cups and then I think that's less impressive than Rubik's cube.
I don't know, Rubik's Cube's crazy.
Have you seen the videos of people that can like lay on their back and like spin a table around on their feet?
That also seems less impressive than the Rubik's cube
Maybe,
thing.
but it's really cool.
Because there are some videos now of it seems to be a trending thing on TikTok with people who are sign spinners, like people that stand outside of like the tax places or Little Caesars, coming in for the pizza, and they're like they can do all sorts of weird sign flips and things like that. Yeah, who doesn't have TikTok? That's one of my main forms of entertainment. Well, I don't know if you want to get your news from TikTok.
That's what I heard about the US Alpha.
On TikTok?
Yeah.
Well, yeah, but it wouldn't have been like some sort of like funny like thing, related to it.
Yeah, once you see like 10 views on something, you're like,
Yeah, I mostly like the ones where
something's really going on.
I mostly like the ones where they make the dogs talk. Dogs just staring out the windows. It's like, what are you doing? It's like, what is he? I don't remember what he says. He's like,
You make TikTok videos?
no. Well, actually, Mr. Gonzalez did make a TikTok video. He has a couple of TikTok videos. I also like some of the ones that are like comedians where the people do the, just the voiceover where they use the voice and they mimic it. It's just, entertainment. And what are they supposed to be stealing your identity or something? Isn't that the thing with TikTok is there's like a concern about security stuff. I mean, I have a website with just all my stuff on it, including a social security number. So if you want it, it's there. Dr. Wall was in the other extreme for security. I'm an open book, whatever you want, it's fine. Okay, so we're going to teach a disk how to display itself. So maybe that's like the number of, maybe we do it something like maybe that's our size 1, 2, 3, something like that, just equal signs. That's a reasonable enough implementation for what a disk looks like. So we're gonna have to do a little stuff with some strings, right? So we'll go into disk. We're gonna now add another function called display. Let's see, do we want, so now we make a design decision. Do we want our disk to actually print a representation of itself out, or do you want it to return a string representation of itself so that somebody else can then display it? I think maybe we want that. So something like that. So maybe we're going to call this guy toString instead to kind of mimic Java's approach to this, because we're not asking the disk to display itself. We're saying, give me a string representation of what you think you look like. So we'll call this guy toString. Yep, correct. And this guy's not going to know what a string is. So we need to include string H. Is it just string? Because it's a namespace, I think. Ninja? Oh, so is it actually part of standard?
Oh, wait, never mind, you gotta use include string and also use.
Well, so
No idea why.
I like string.h there, and then you can say std : like that. Is that gonna make it work, or does it want to have? All right, so it's the string namespace, and this guy lives inside of std. So you could say using namespace std up here, or in this case, since we're not doing it in a zillion places, I just said string belongs to std. So we'll go into our implementation for this guy. And we don't need to include string here because it came with our disk HPP. All right, so this guy should return a string that has a number of equal signs that is twice the size. So maybe we say string answer is equal to the empty string. For int I is equal to 0, I is less than this size. I plus plus, answer plus equals that, return answer. And this guy belongs to the disk class. I think it's called size in here, right?
Oh,
Yeah, tower has a count. We said a disk has a size. All right, so there's our toString. So that's a disk telling us about its what it should look like. And we can actually, we're probably getting to the point now where we should probably start testing a couple of these things as we're going. So I'm gonna actually go ahead and give ourselves our driver. All right, and we'll do include, we've been doing IO stream in here. And we've been doing using namespace for cout, right? Int main, int char, c char pointer. And then we'll return 0 at the end. We're going to go ahead and include disk HPP. We'll go ahead and create a couple of disks. Disk pointer D1 is equal to a new disk of size 1. D2, D3. Something like that. And then we'll do cout D1 2-string. And we'll do that for the other ones, just making sure this guy gives us what we want. Oh, Ninja. So we'll create 3 instances of our disks, ask each one to display themselves. So we should get a representation of what our disks should end up looking like. Glasses is 300. Call it. Oh, I didn't get into the directory yet. So we'll say GCC star.cpp. Row. Oh, it's not GCC, it's G++. Okay, and then we'll just do this with disk. All right. So there's our towers. That looks pretty reasonable. Originally, I was thinking GCC, which is a C compiler. It doesn't know C++ stuff. So G++ is our C++ compiler. All right, so these look like pretty good representations of towers. All right, so now let's go teach a tower how to display itself. So let's see, do we want I think we should probably have a tower actually able to display itself. I think that'll make the most sense. So we'll go ahead and say void display. And then the implementation for tower, we haven't even written push yet, that's fine. All right, so for the implementation for tower, we want to go ahead and have this tower display itself, which is going to mean we're going to walk down the stack. Now remember, this stack is effectively a linked list, right? We typically work with it using pushes and pops, but because I have direct access to top here, nothing keeps me from just walking down this, right? So this should ask, well, this should do a see out on each disk's toString for the entire tower. So take a couple minutes, try to write the code for display. I know we haven't written push yet, so we can't really test it yet, but the rest of this is, you should be fine. I mean, treat it as a stack. Write the code that will go through this and ask each disk to display itself that's on the tower. Remembering that top points to the top disk on the tower. All right, so let's take a look at this. So for display, what are we gonna do? Well, we're gonna start at the top of the stack. So we're gonna go ahead and create ourselves a disk pointer curdisk is equal to this top, while curdisk, well, that's a thing. What do we want to do? We're going to go ahead and do cout curdisk toString. You already put IOStream in here? No. I probably just need to use namespace. Oh, okay. It does. So we'll go through, we'll tell each thing to cout curdisk toString endl, and then we'll say curdisk is equal to curdisk get next disk. So we'll just run curdisk down our stack. But keep in mind, you do need another pointer like curdisk because you don't want to change the top of our stack. So as long as curdisk is a thing, so you can say, well, curdisk is not equal to null, or you could also do this as a for loop. You know how many times you have to go through. You could say something like for int I is equal to 0, I is less than this count, I plus plus. You know this is the exact number of disks you have in there that you're going to have to go through and display. So kind of pick your poison on whatever you think is the right way of writing this loop. I would say this is the old schooly pointer way of doing it, something along those lines. All right, so that's display. Let's go ahead and push, write push for this guy. For right now, let's write push with no rules associated with it. Okay, so we won't have towers of Hanoi rules. We'll just say, look, we're putting something on top of the stack, whatever that means, okay? So add an element to the top of the stack. Don't implement Tower of Hanoi rules yet. All right, take a couple minutes, try to write that guy. All right, so let's look at this. So pushing something onto the top of the stack means that this guy needs to point to whatever top currently points to and then make top point to this guy, right? So D set next disk to this top. So he should point to the same place that top points to. And then we can say this top is equal to D. So that will push an element onto our tower. Go ahead. Yep, increment count. We have one additional thing now on our tower. All right, so that's push. Now we can go back to driver. And I can go ahead and I can say, tower T is equal to new tower, and this is a tower pointer T, and we need to include tower HPP. And then we'll say T dot push. We'll even do this in the right order. T dot push. So we'll push the 3 disks onto our tower, then we'll tell the tower to display itself. Use definition. Oh, this is that if and define thing. Yeah, so as it stands right now, let me just show you what the actual issue is. Because tower implements disk, we actually don't need disk there. We can just call tower, and tower comes with include for disk. Okay, so now that works, but notice here we do have some issues like this, and this is where that if and define thing comes in, where we can say, if it's not already defined, include disk, include things like that. I'm gonna leave it like this for right now because this isn't gonna bust anything and short on time. But that's what it was yelling about, is I was including inside of driver, I was including disk HPP as well as tower HPP, and tower included disk HPP. So I was actually including that twice. So it was yelling at me saying, hey, you've already included this before. All right, so there is our tower displaying itself. All right. So now, have we started writing game yet? New file, game HPP. We decided a game, so we have class game. This guy is going to have a private section where we're going to have a collection of towers. So we will include tower HPP. And we're going to go ahead and have a tower pointer array called the towers that will hold 3 towers. All right, and this will actually generate the memory for that tower array. I would say this is not the new cool kid way of doing it. New cool kid way of doing it would be with malloc, right? So you'd actually have a tower pointer. It's a collection of tower pointers. So this would be a, yeah, this is fine. A tower pointer called the towers. We point to a single tower. It points to a single tower, which then points to another. Yeah, that's actually a really weird way of thinking about it. Because like, for instance, an array of strings is a string pointer. But technically an array of towers is a tower pointer. Because the pointer holds, bucket 0 would be whatever it would be, the towers plus 0 times size of tower. Tower of bucket 1 would be the towers plus 1 times size of tower. Tower of bucket 2 would be 2 times tower size of tower. We'll write it the cool kid way next time. For right now, just so I can give you some homework, we'll write it that way. This is going to be an array of tower pointers, where each bucket has a tower pointer. And for our, we'll have a constructor in here. The constructor will be called game. And this guy should set up our initial 3 towers with the disks on the far left. And then we should also have a function called display that is void. This guy should show the 3 towers. I'll display the 3 towers on the screen. And I can say, you can do this vertically. So you don't have to try to do the math where you have a tower followed by another tower followed by another tower to make it look super legit. You could just say tower, tower, tower. So they're right on top of each other. It's not like we're going for an amazing user interface type situation here. But again, probably a better use of time than 8 towers of Hanoi. So if you wanted to go ANSI with this and also have your towers next to each other, have that. That would be a better use of the time, but I'm not going to write it that way. Whatever. So let me. Call it in GitHub. push. And we'll push this guy. This is going to go to of Hanoi. Okay, so I'm going to go make my repository real quick so I can give you the link for this. And then your homework will be to implement game and have it show the initial game board. Okay, you don't have to make it play the game yet, but implement game and have it show the initial game board. So I'm just going to go and create my repository real quick. You can, if you want to watch, you may, but repository CSC 300 spring 2021 Towers of Hanoi. Oh, we could do by get branch name. All right, so now that guy's up there. All right, and I will see everybody on Thursday.